Hitesh sir, am I audible? Hello?
Yes,
Hello.
yes, you're audible.
Yes. Here I'm inviting Mr. Assistant Professor Hitesh Parmar sir here for giving the webinar on Industrial PLC Applications. Right now he is working at a MS University as an assistant professor, and he has 2 to 3 years experience. And he also completed a master degree in electrical engineering from the MS University. So I request to Hitesh sir, please share your slides, and you can give the knowledge regarding the industrial PLC applications.
Thank you, Vinayak sir and Parul University to give me the opportunity to share my knowledge with the student of the unit. Can you see my screen? All of you? Hello?
Yes, sir, it is visible, sir. Please continue.
Is it visible?
Yes, sir. Yes, it is visible.
Okay,
Please continue.
so let me introduce myself. I am working as an assistant professor in MS University since last 7 years, and my major subject is industrial advanced instrumentation and microcontroller and microprocessor. Okay, so today we will share some knowledge about the PLC, which kind of the PLC is used in the industry. Okay, so let me first introduce how the PLC looks like. Okay, so PLC is see why the PLC is the most popular nowadays, because as you know, if the hardware control or hardwire instrumentation will be there, and if you want to change the from logic, like from you have defined that C is equal to let's A or B. Now you require to change the knowledge C is equal to A and B. So you have to change the you have to change the logic regarding that. Okay, and you have to change the hardware, but instead of that in PLC, that is the programmable logical control, so just you have to change the logic in your program and you do not have to change the hardware. That's the advantage. Okay, and nowadays PLC are the most popular because it is easily connected with the outer or field side, with the from relay, with the from digital output, digital input, from sensor, from transducer. Directly we can connect with the PLC. Okay, so in industry there are different kind of the PLC, different kind of the different manufacturers are available. They are manufacturing the different PLC like Siemens, Schneider, Allen Bradley, and G. There are so many PLCs are available in the industry. Okay, so nowadays in India, Siemens are the most popular PLC. Okay, so today in this seminar we will see the basic of the PLC, and then we will start we will try to implement some industrial application or some home automation application based on the PLC. See, if we want to operate just only the simple switch or simple logic control, then PLC is not suitable because the costing of the PLC is more. But whenever we require the more number of inputs are there, more number of readings or more number of transducers are there to take the reading, like the pressure, temperature, flow meter and all that, and we have to control those all the parameters, then PLC is the more suitable because in PLC, generally PLC is what? Programmable logic control, and whatever here programming is there, that's not the coding. But ultimately, we are doing the programming in PLC like the what we can say the ladder diagram. Okay, so let's we first go through the basic of the PLC, then we try to implement this kind of the PLC. Okay, so today's main objective of this lecture is to understand the concept of the PLC and application based on the PLC. Okay, so PLC is what basically a controller the parameter of the system that affects the performance. Okay, and uh, see, it can why it's known as the programmable. It can be reprogrammed for the different tasks by the end user. If you do not have to change the PLC hardware, just you have to change the uh, logic in the ladder diagram, uh, uh, and directly it will be changed into the hardware file. Okay, so these are the basic part of the PLC, because see, this is the microprocessor based PLC, because we have to store some whatever the program, whatever the ladder diagram in the memory, so we require the memory. Also, we have to connect some digital transducer or analog transducer to the PLC, so some inputs are required. Okay, like switching, control switching, and all that, time limit switch, control limit switch. Also, we have to give some delay for timing. Circuit will be inside the PLC. Okay, and why PLC is used in the industry, as we have discussed just now. Okay, it can withstand the vibration, temperature, humidity. We do not have to worry about its internal architecture. Whenever we do the programming in a microcontroller or microprocessor, okay, at that time we have to worry about the internal architecture of the microcontroller, internal architecture of the microprocessor, its timing diagram and all that. That's kind of the what we can say, that's kind of the structure we do not have to remember in the PLC. Okay, hardware relay logic, automation is most widely used in the automation in industry. Like one kind of the assembly line will be there, some packaging will be there. Okay, some painting will be there, 3D. If you want to implement some 3D printing circuit like that, if you want to count the number of production in the industry, then in this kind of the circuit, PLC is most widely used. Okay, uh, and its input and output module can be extended depending on the requirement. As see the whatever the PLC before the 5 year, 10 year, those have only the digital input and digital output. So we require extra ADC, DAC connect with it. But nowadays it has internal ADC, DAC, so we can directly connect the transducer with it. So this is the basic structure of the PLC. Okay, processor, input module, output module, power supply. Here some memory is also required. Okay, on the input side, some sensor will be there, push button, limit switch. In output module, some solenoid, contactors, alarms, motor, etc. Okay. Programmable logic controller. These all are the basic part of this one. Okay, means what is the task of the CPU? So it performs the routine task, because whenever we on the PLC, we have to maintain some basic program. Okay, which program it has to follow. That's why the CPU unit is required. We have to store some input address, output address. So we require some ROM memory. Also, we have to store our own program that can be stored in the RAM. Okay, program are entered into using the input unit. Okay, and there are different kind of the software are used, different kind of the notation are used based on the which manufacturer are there for that PLC. Okay. Then main is what? Ladder diagram. Ladder diagram means what? It is one kind of the programming language like C. It has some syntax like a microprocessor, microcontroller. It has some assembly language. Same way in PLC, it has some programming language that is known as the ladder logic or ladder programming language. Okay. Why? Because here, see, here I can show one. See, okay, this is the one kind of the PLC diagram. Okay, this is whatever the vertical line that is known as the rail. So if one rail fed, that is the 230 watt if we supply, or 24 DC supply to operate this input, another rail fed is connected with the ground. Okay, and it looked like the ladder, that's why it is known as the ladder diagram. Okay, and each rung, each horizontal line is known as the rung. Okay, for each rung have multiple input with the multiple logic. Either you can connect the multiple input in series, multiple input in the parallel, but only one output in the one rung. See, you can never connect the multiple, what we can say, multiple uh, multiple in output in the single rung. Okay, also you can comment for each and every rung. Okay, comment for rung 3 means here we also can give the tag name, means according to the PLC, according to the PLC manufacturer, whatever the input notation, output notation is different. Some PLC has the notation like I0.0. Some PLC has the notation I0, I1, I2, I3. Some PLC has the notation O0, means output 0, output 1, output 2. Some PLC have the Q0, Q1, and so on. Okay, but those all are known as the notation basic. Okay, again microprocessor operates here internal, there is a microprocessor, so we know that always the whatever the microprocessor that can be act on the only the digital logic, means 0 or 1. So there are two kind of the event occurred over in the PLC, 1 or 0, true or false, on or off, high or low, yes or no. Okay, and ladder, how to read the ladder logic. Okay, so events like a button being pushed or a limit switch being activated. Okay, real world event is translated into the ladder logic and expressed in the form of the normally open context. Okay, there are two kind of the switch. See, here let's we consider one event. It has the two state, true or false. Okay, event is associated with the normally open context, can be true or false. See, if the event normally it is open, if event is true, it will be green, means it will be short circuited. It will be connected with the next whatever the connection will be there. Okay, see ladder logic diagram. So if यहाँ पे see here we are using the ANO connection. Okay, here we are consider this event A, and normally that is open. If it is energized, ultimately these inputs are what, one kind of the relays and all that. So relays are what, ultimately the magnetic field. So it can be energized. Okay, so whenever it can be energized, okay, this will be the closed and output is one. Okay, and this horizontal line is known as the rung. Okay, and first line of the code. Okay, again same thing is that if A is false, then Y is false. If A is true, and then Y is true. Okay, so we can implement so many functions here. There is a one basic example of the AND, basic example of the AND gate. Okay, so see, if A is true and B is true, then Y is true. Okay, see, when if normally both the inputs are ANO connection, if one relay is energized over here, but B is open, so there is a no supply will flow from one rail to the another side of the rail. So output is disabled. When both are one, at that time this will be the act as a short circuited, and we can get the output Y is equal to 1. Okay, so this is the simple logic, and we can implement so many functions like that. Okay. Okay, then after the whatever the ladder diagram proving, what will the process occurred by the PLC. So it will scan the input associated with one rung of the ladder diagram. It will follow the logic operation. fat or reset the output for that, means according to the whatever the logic, it will set or reset the output for that term, move on to the next term and repeat the operation for all one. See, as we know that in assembly language or in C language or any kind of the language, whatever the program, those are executed sequentially. Means whatever the instruction executed, that will be the sequentially always. Same way in PLC, whatever the ladders or whatever, not the ladder, whatever the rung, that those all are executed sequentially, means one by one. Okay. So, so PLC then goes back to the beginning of the program and start again. Okay. Here one example is given. Okay. Okay. Input one, if input has contact not close until the input. When output A occurs when input 1 is there. Okay. Now, देखो, see, one input is occurred over here. Okay. Now, input is unable. If you have used the switch for the input 1, so it is already okay. Then when we operate the input 3, output B occurs, and when input 1 and input 3 is occurs. Okay. In see the third rung. Okay. When output C is enabled, so either input 4 or either input 5 operate or occurs or energized. At that time, output C is occurred. Okay. So before starting the PLC application, let's we discuss about some selection of the PLC. Okay. So whenever we choose the PLC for our application, either industry application, either the home automation application, this criteria should be a match. Okay, means how many inputs we require, how many outputs are required, which kind of the control system, which type of the automation system we have to develop, which kind of the communication protocols are required. Means sometimes we have to load the PLC using the our PC, and PC is connected with the PLC with the hardware. So normally the USB cable or USB protocols are used to load the PLC. Sometimes or some in industry, PLC are mounted or PLC are fixed in the from field side, and whatever the control, whatever the software installed in the PC, those are in the remote area, and then the PLC. Then we have to use some Wi-Fi based protocol or wireless protocol to transfer the program into the PLC or to read the program from the PLC to the PC. Okay, so according to our requirement, we have to choose PLC. Okay, so see, isolation means PLC mounted on some device. Okay, and if the temperature around that field is more than 400, 500 temperature, 400, 500 Celsius temperature, then PLC will be melt. So proper isolation is required, signal conditioning, input output capacity required, as we have discussed how many inputs and how many outputs are required, speed and power required for the CPU. Okay, speed is the main concern. Okay, if it takes more time to read the input, to read the logic, and to transfer the whatever the output to the field side, and it takes the more time, then sometimes we cannot control the whatever the change occurred in the field. So also the speed is required for that CPU. Okay. So let's now discuss about the PLC application. Let's here we see there is a time limit, so it's not possible to perform the hands-on one-to-one what we can say the simulator over here. Okay, but I will try to see. This is the go down wiring. Okay, one kind of the go down wiring. So we know that go down wiring is what when we enter the room. if we start the first switch, okay, then we move to the further side, and if we press the second switch, at that time the first light here, first light will be off, and so on and so on. Okay, so such kind of the logic, let's we if we develop in some industry. Okay, so how can we develop this logic? How many inputs are required, which kind of the supply is required. Okay, means when we press the first switch, at that time first bulb will be on. When we move to the second further, and when we press the second switch, at that time the second switch must be, second bulb must be on. Okay, let's we try to implement this one. Okay, so here some logic is developed over here. Okay, let's I will try to just a minute, I will try to share my whole screen over here. Vinayak sir, can you see my the desktop?
No, sir. I just see your PPT. Right.
Hello,
Yes, sir. Your PPT is visible, sir.
am I audible?
Not your desktop, sir.
Just a minute, I will try to share my the desktop screen so I can show the software regarding that.
Yes, yes.
Neat. Vinayak sir, can you see my desktop screen or only the presentation?
Sir, I right now only see your presentation.
Sorry sir, I am not, you are not audible.
Sir, right now I'm only see your presentation, sir, not that desktop screen, sir.
Okay. So just a minute, I will try to stop this. Okay, now Vinayak sir,
No, sir.
can you see my
Yes,
desktop
yes,
now?
yes. Now it is visible.
Okay, okay. So, see, students, there are so many software, different software for the different PLC. Okay, here normally we are using the Schneider PLC, Siemens PLC. According to the Schneider PLC, there is one software you can also install in your PC. It is freely available. Is freely available on the internet, and you can enter that software in your PC. Okay, so muffin basics. It's till that we try to understand this. Okay, so let's we develop the logic over here. Okay, uh, we try to see just okay. Let's we try to implement this logic over here. When we enter the, let's, this is the I0 switch is used for the first light. I1 logic is used for the second light. Okay. Just a second. Okay, see, how can you use this software whenever you want to implement the means whenever you want to create the new ladder diagram, you have to do the create new project. Okay, this is the software to implement the Schneider. This one, let's try. We try to show how can you implement. Okay, click on the create a new project. Okay, now you can see that here M221 logic controller. So there are as you know that if you have used the Kale, or if you have used the STM32 simulator ID. Okay, so there are some option, means you have to select. Simulator is what? Simulator is what? There is no actual or physical hardware will be there. but virtual platform will be there where you can see your inputs, you can implement your logic, and you can check your output according to that. Okay, so you can select any device from here. Okay, let's I select this TM221C43 over here. Okay, so you can see that here the device description will be there. So see, it has the 14 digital input, 10 force, means 10 outputs will be there. Okay, 2 analog input, 1 serial line port, and 24 voltage DC supply is required with this terminal block. Okay, so as per your requirement, you can select the device, you can purchase the PLC, and any of the PLC program you can do that programming here. Okay, now see, this is the programming window or ladder window. Okay, how can you implement this one? Let's we try to implement one PLC. Let's we develop one logic from here. Okay, so these all are the inputs, these all are the output. Also some timers are available, some counters. Counters means let's you want to define some car parking system or from production assembly, and you want to count the 1,000 production or count the 500 production. At that time the counter is required. Okay, shift bit register. What is the importance of the shift bit register? If there is a one digital number and if you flip the left side, okay, that means you are multiplying that number by 2. If you multiply, if you flip the register by 1, means if you do not okay, if you flip the register right hand side, okay, then you divide the number by 2. Okay, and there are so many functions available in the PLC. You can also give the pulsating input over here. Okay, you can also transfer the message according to whatever the input. Let me try to implement some. But this is known as the rung. Okay, if you want to add the new rung over here, you can add the rung by this way. Okay, you can also delete the rung from here. Okay, Vinayak sir, is there any lagging between whatever the software is going on or my voice?
No, sir. No, sir. It is very much smoother. Sir.
Okay, let's we try to implement the one simple and get. Okay. Okay, so see, there is a one input. Also, we require the another input. Okay, and we require the one output over here. Okay. Now, see, there is the symbolic address and all that. So you can give the address from over here, or here there is some option like tools. Okay, so digital inputs are there. Okay, so you can see the notation I0.0, I0, and we have the 14 inputs for this control. Okay, so we can give the any address from here. So you can see that now the address is I0.0. Okay, let's we try to give the another address, that is the I0.1. Okay, now also we can comment the wrong. Let's we here give the name and get implementation. Okay, so whenever the number of rung is more, okay, we can give the comment to each rung. Also we can give the comment to the input. Let's यहाँ पे हमने comment कर दिया A input. Okay, here we can give the B input. Okay, and for the output notation, directly you can click over here and you can change, or see here in the tools there are option, that is the digital output. So you can directly track that output from over here, and you can give the name whatever the output will be there. Okay, so this is the basic gate. Okay, now here we just implemented a normal AND gate. Okay, if we want to add the rung from over here, if you want to remove the rung, okay, you can draw the line. Means, see, there is from line with, if you want to make the connection, okay, then you can use this pencil to connect like this. Okay, if you want to erase something, you can use that one. Okay, so as you use this software, you will be aware of whatever the input, whatever this menu bar and all that are there. Okay, so let's see, now we try to implement. So after connecting that, we have to compile. As you compiling the program in a C or in a my 8085 or 8051 programming, same way here you have to compile this ladder diagram or ladder logic. Okay, so here you can see that the one. Okay, so see the compile program. Okay. So as you compile program, there is no error. Okay. Here you can see that there is no error. If some error will be there, that message appeared. Message will be appeared over here. Okay. Now, what you have to do for that, you have to go into the commissioning. Okay. Now see, actual hardware is not connected right now. If the hardware is connected now, then you can see that whatever the hardware is connected over here, that will be here. See again, if you connect from Schneider hardware, Schneider PLC with the your PC or the laptop, then you can see that model number over here. Then here there is a two option Ethernet device. Means you can transfer the logic by Ethernet device, or there are another option that is the USB bus. Okay, so we have the two option for that. One is the USB bus and another option that is the uh, what we can say the Ethernet protocol. Okay, but right now we have not connected any hardware. That's why you can see these all are the disabled. Okay, right now we have just only the simulator. So let's we see how can it we can simulate. Okay, so you have to select the launch simulator. Okay, then now you can see the input over here. Okay, you can see your controller, means whatever the hardware you have connected over here. Then what you have to do, you have to start the controller from here. Okay, now you can see your programs from here. Okay, now let's here we are using the two inputs. Okay, so you can see that right now that is the black. Okay, and if you want to enable that, then just click over here. So see up you can see that green symbol over here. Okay, right now that is the true. If you press again that one, it is converted into the false. Okay, now you are giving the one from here. Now it will be the true, but output is still false because we are operating the AND gate. Okay, let's we push this button and we try to give one to the input one. Okay, but still output is low because both the inputs are not enabled right simultaneously. To keep the output on or to keep the output high, we must require both the input. So now you can see that both the when we enable both the input, output is high. Okay. Now, if you want to change the logic over here, if you want to change the logic over here, first of all, what you have to do? From here, you have to stop the simulator and stop the controller. Then and then you can change the program over here. Okay. So let I try to implement this software. Okay. Go down wiring. Okay. So let I have already made some projects for you, okay, because it's let's we try to implement the go down array. Okay, let we can see that logic over here. Okay, already we have this is the bulb one, this is the bulb two, and this is the bulb three. Okay, and let's we try to implement this one. Okay, whatever our logic is implemented over, that is true or not. Start controller. Now you can see that logic. Okay, see this is zero I 0.0, that is the first switch which is used over here to operate the first bulb. Okay, uh, this is the second switch. Okay, for the I0.1 is used for the second bulb, and I0.2 is used for the third switch, means third bulb. Okay, so let's we try to implement this logic over here. Uh, just you can run from over here. Okay, so you can see that first bulb is on. Now we are moving further. Just a minute. We are moving further to the next one. At that time, when we press the first switch, the second bulb must be on, and simultaneously first bulb will be in the low mode, or will be off. So let's which switch is used for the second bulb, that is the I0.1. So let's we can change the its input logic from over here. So you can see that now the second bulb will be on and the first bulb will be off. Okay. Now we move to the third bulb. Okay. At that time this will be on, means this will be off. This will be these two bulb will be off, and this will be the on. Now we moving. Now we are trying to off from the go down. Then if we off the second bulb, see at that time the third bulb will be off and the second bulb will be on. Now we moving to the door side. Okay, this bulb will be off and this bulb will be on, and last one is this. All the system will be off. I think you can understand this logic. Also, if you are interested in the PLC programming, you can implement this kind of the program, and you can check your input output logic over here by the simulation. Okay, it software name is Machine Basic. It is freely available on the internet. You can download the software, you can install in your system. Okay, and you can check the whatever the ladder diagram in this. Okay, let's we move to the next problem. Okay, so next problem is what? Okay, let's try to implement the next program. Okay, here we are controlling the one phase motor by pressing the start and stop push button. Okay, and motor should remain in on state after the start push button. Okay, means here there is a no switch, one kind of the push button switch, means you do not have to press the push button till the motor is done. Just when you press the push button and you off the button, but still motor is on. Okay, such kind of the logic if we want to develop. Okay, like the key in the car. Once you start the car and continuously, you do not have to press the switch. Okay, same way over here. Okay, just kind of the motor. Okay, there is the push button for the start, That is the push button for the stop. And ultimately, in between, whenever some error will be occurred, and if you want to check the error, okay, you can check the error using this test button. Okay, so let me try to implement this logic using the PLC. Okay. Okay. So I try to uh, implement this motor logic over here. Okay. We have the more examples. So we try to implement this logic. Open the project, the motor test. Let's first of all we try to understand this logic over here, and then we okay. So here I have used the I0.0 input to start the motor. Okay, then to continuously in the run mode after the pressing the push button. Okay, you now push button is unpressed, but still motor must be on. So how can we develop that logic? So whatever the output side logic that can be used as an input over here with the parallel line with this one. Then and then you can develop this logic over here. Okay. So see Q0.0, that is the motor output that can be used over here. Okay. Now we require one button, a push button to stop the motor. So see here we have used one connect push button logic to stop the motor, but normally NC connected will be there. So normally it will be the one when the input one is energized. When the input one is energized, at that time, what is happen? This switch will be low. This switch will be low. Okay. So if there is no supply to this motor, and motor will automatically. Okay. And here also we have used the NC signal for the error signal. So if the error will be there, okay, if the error will be there, this will be into the open mode. So there is no supply is going into the motor, and ultimately if error will be there, motor is not working. Okay. Also we can check the motor from this test motor. Okay. Let me try to run this program over here. Okay. Okay. You have to go into the commissioning, then start controller. Okay. Now let's try to compare this logic from here. Okay. First of all, we have to check the motor. Okay. Let's check the motor testing. Okay. So motor testing के लिए देखो. If I prove the true, so there is no error signal, motor will start, means there is no error. Okay. So it can be checked from here. Okay. Let's make it 0. Okay. And this will be the off. Okay. Now let's stop the motor के लिए press 1. Okay. Now see, when we press the 0 button over here to start the motor and again make it 0, push button है तो एक बार press करके there is a push button, so if we press it become a 1, then when we unpress that button it becomes the 0, but still motor is on. But that is the logic of the push button. It is not the normal switch. Once you press the push button, motor automatically start and it continuously in the run mode, and it can means it has the supply from this parallel path. You can see that green path. Okay. Now if you want to stop the motor, so there is a logic for the I0.1. So we can press that button. Okay. So you can see that motor is stopped. Okay. And for the test logic. Okay. So by this way we can implement the for many logic here. Okay. Now let's try to implement this more example. Okay. Okay. So here one system is there to mix the two liquid. Okay, in an industry. Okay, so here what is the logic over here? Up to the limit x1, we have to mix the liquid 1. Up to the x2, we have to mix the liquid 2. Then after uh, and for the liquid 1, okay, for the liquid 1 there is a one inlet. For the liquid 2 there is a second inlet. Okay, after mixing two after reaching the x2 level, I am explaining the whatever the question. After reaching the x2 level, there is the motor y3 will be there. It is used for the mixing this liquid. It is used to mix this liquid. Okay, so motor y3 is the mixture. After mixing, there is a logic. Okay, we have to mix the both the liquid for the some time period. So here we have to use the timer for that. After mixing the both the liquid, there is a one outlet will be here for the y2, and that mixture outlet must be on for some time period. Okay, and here start stop button means there are another system will be there to start the system, to stop the system, and some emergency will be there, then we have to stop the system. Okay, so such kind of the logic in industry we have to develop. Okay, so let me explain that whenever you want to implement any kind of the PLC logic, first of all you have to define how many inputs are required, how many outputs are required, which are the transfer output, and all that. Okay, so here it is the number of PLC. Means there is some bifurcation of the input and output required. So X0 is the start switch, X1 is the low level float sensor, X2 is the high level, means whenever the mixture 2 will be reached at that position. Okay, means up to the level X1, mixture 1 means outlet 1 will be on, sorry, inlet 1 will be on. After reaching the X1, automatically inlet 1 valve will be closed and inlet valve 2 must be on, and so on. And after reaching the X2 level, both inlet valves must be off, and at that time automatically this motor Y3 for the mixture that must be on for the particular time period. Then after mixture must be on. So according to that, there are number of outputs required, number of the PLC. Okay, here to understand the example, we have taken the timer T1 for the 6 second and T2 for the 12 second. Okay, and here some example distribution of the ladder diagram is given. Okay, let me try to understand with this one. Okay, with this ladder diagram. So such kind of the logic we must have to develop over here. So whenever whenever we press the I0 switch for the out for the inlet one, again I0 switch is for the inlet one. So see, when we press that switch over here, it must be on. So inlet valve will be on. Okay, whenever it reach to the X1 level, तो X1 लेवल के लिए इनपुट क्या है, इनपुट 1, तो वो एनर्जाइज हो जाएगा, it will be energized. So whenever I1 will be energized, this must be closed and this path must be off. So at that time, inlet valve 1 will be off and inlet valve 2 must be on through this path, through using a round 1. Whenever it reach to the X2 level, at that time inlet valve 2 must be off. So see over here, whenever this bit will be done, at that time I2 sensor will be on, I2 sensor will be on at that time, this will be de-energized. So round way 1 will be disabled. So at that time automatically inlet valve 2 must be off. Suddenly we have to start the mixture. So for that O2 output is required for the mixture. Okay, so it will automatically on, and see here timer done bit will be used. Timer done bit. So I2 is used to start the timer. So there are two kind of the timer, T on timer and T off timer. So here I2 switch will be used to on the timer. Okay, so it will automatically on over here and it will start the timer. Okay, after the 6 second, this timer bit timer done bit will be 1. At that time this T1 done bit will be 1, so this must be off, so automatically mixture motor will be off. And at that time whenever the T1 done bit is used to start the outlet valve, so here T1 valve will be used for the outlet valve to start the, and it must be on for the 12 seconds. Okay, so this kind of the logic you can develop for that. Okay, again let's we try to understand. We have the very means time limit right now, so let's we go through the simple this program. Okay, there is a buzzer system. Okay, there is one host, there is the one pupil group, one the high school student group, and third one is the professor group. But this quiz competition is little bit tough. Uh, this buzzer will be on after host will enable this X5 switch. Okay, again, whatever this whole buzzer system will be on. Okay, when this host will enable the buzzer system from here. Okay, now there is a one condition. If there are two pupils in the first group, either of one press the buzzer button, at that time this buzzer will be on. Okay, here only the one student, so whenever he pressed the button, he will press the button, this buzzer will be on. For the professor group, if both the professor will press the button, then and then buzzer means buzzer of that table will be on. That is the condition. Here either condition will be used. Here only the one student, and here two professor will be. Therefore, it must be on when both the will press the button. But simultaneously, we have to develop the logic like that. Whenever, let's assume that X2 means high school student group press the button first, at that time, the buffer system for the pupil group and buffer system for the professor group must be disabled. Or vice versa. Whenever the pupil group of the buffer system on, at that time, the buffer system of the another two must be off, and so on. This kind of the system we have to develop using the PLC. So let's we try to implement that budget system from here. Okay. Let's try explain that with the PLC so you can be more clear for that. I try to open that one. Okay, buffer system. Let me try to implement that buffer system over here. Okay, see here the first rung will be used for the two pupil 1 and pupil 2. Okay, And here we are implementing the either system, means either pupil 1 or either pupil 2 press the button, at that time buffer A must be on. That's why we have used the parallel path over here. Okay, and this is the push button logic again, as we have discussed with the motor. This is the push button logic, so we have to use the Q0 parallel with this one. Okay, same way, whenever the this rung is used for the high school student, so it is the single person, so there is only one input is required. Okay, and here the third buffer will be on when both the professor 1 and professor 2 press the switch. That's why we are using here the series logic. Okay, now see the logic over here. Whenever we press this button, means either of these two press the button, at that time Q0 must be on. Okay, Q0 must be, and see this I05 will be the host button switch. Okay, so he or she can disable the whole system by pressing that switch. Normally it will be high whenever he or she asks the question. Okay, it normally high. Okay, so see, whenever we press the I0 button over here or I01 button over here, it will be energized and its NC connection are, means at that time this Q0 button will Q0 buzzer system will be on and its NC connected used over here. See, please see this calculation. It's NC connection used over here. So whenever the buzzer 1 is on, at that time normally this will be the NC connection. So when it will be energized, at that time this will be off. Okay, so these two can press the button, but still there is no buzzer system will be operated. Okay, let's we try to understand with what we can say in the run mode. Okay, there is a one question will be asked. Okay, and any of the two people group if press the button, okay, then buzzer system will be on. Okay, and till it will be on. Okay, now let's after that, if the student, high school student press the button, but still its buzzer system is not on. Why? Because of the buzzer A system will be on. Okay, it will be off over here and it will be off over here. Okay, and let's professor, both the professor press the button, but still it their buzzer is not enabled because first of all whatever the buzzer will be enabled by the pupil. That's why. Let's we reset that system from here. Okay, let's we try to make it all 0. Okay. Okay, now let's pupil 2 will press the button. Okay, so you can see that this buzzer will be on. Okay, now if we if some pupil 1 or pupil 2 press the button, then still its buzzer their buzzer is not on, or vice versa for the professor. Okay, so you can implement such kind of the logic using that what we can say using this ladder diagram. Okay, now let's we try to implement the last one. Okay. Let's we try to implement the traffic control system. Okay, in India traffic system is not much so accurate. Okay, but here try to implement. Here we are using the timer on system. Okay, here we have used the timer. Okay, for the yellow light, for the red light, and for the green light. Okay, actually there is a mistake for here, because first light will be yellow, then no, it's fine. Yellow, red, green, and green के बाद again yellow, then again red and green. Okay, so see here for that we have used there is a three different kind of the timer for that. One for the 7 second, one for the 10 second, and one for the 7 second. Okay, and see whenever the system is on, okay, and when the input is on, after that whatever the traffic system, that must be in a continuous run mode. Then and then we can say that it can be act as a normal. So how can we develop the logic? Simple. Let's we try to develop the logic in our mind. So normally here we are using the three timers. Okay. Whenever the timer 0 or timer 1 bit will be enabled, at that time it will counting the time. After reaching its preset value, okay, it will try to off the whatever the remaining on light, and it will try to on the next one. Means that timer done bit is used to on the next one and off the previous one, and so on. When the second timer is counting, at that time the second light will be on. After the done bit, it will be off, and third light must be on. Such kind of the system must be there. Okay, so see this done bit Q0 done bit is used over here, so it will automatically off this light. Okay, automatically it will off the light and it will on the next light, and this done bit is used to on the next one. Okay, such kind of the system developed over here. Okay, so let's we try to run that program over here. Now let's we start the timer 0. Okay, so automatically this timer will be start from over here. Just a minute. Sorry, I have not started the control. That's why we are not getting the program. Okay. So let's we start the timer. Okay. After the 7 seconds system, it will automatically on. See, now that this green light will be on, you can see that. Then this one, then 0, and so on. Again 0, 2, 1, 0, 2, 1, 0. Okay. Just I have given the comment wrong over here. Just I have to change the, I have used the timer 0 for the red and timer 1 for the, sorry, timer 0 for the red and timer 1 for the yellow. So just in comment I have written the wrong information. Otherwise it will be fine for this traffic control system. Okay. For using this software or using the PLC, you can develop so many logic here. Okay. So I think we have to stop over here. Okay. If any student has any doubt regarding the software, regarding the PLC, regarding the logic, they can ask for that. Okay. Thank you, everyone. Thank you, Parul Institute and Vinayak sir, to give me this opportunity to share my knowledge with the student.
Yes,
If any student or any faculty have any doubt regarding the software, they can ask. Am I audible, Vinayak sir?
Yes, sir. You are audible to me. Yes. I think no one is there, sir. I think. So we'll conclude our meeting over here, sir, our webinar over here, sir. Thank you so much, Hitesh sir, to give us this type of important knowledge and concept regarding the PLC, sir. We all are also use this knowledge to improve our knowledge regarding the PLC. And finally, I also like to thank to my Bharat University team to give this type of opportunity to me that conducting this type of webinar on this such a big platform. Thanks a lot, sir. Thank you, Hitesh sir.
Thank you, Vinayak sir, and thank you, Parvati University. I hope we will see in future and share our knowledge to each other.
Yes, sir. Definitely. Sure.
Thank you.
Thank you.
Okay, Vinayak sir, can I leave?
Yes, sir. Yes. Yes, sir. Sure.
Okay. Oh.